All right, today we're going to talk about zeros of a polynomial, but before we do, we're going to talk a little bit more in depth about that intermediate value theorem. So in the last set of notes when I discussed it, we talked about if one number is positive, one number is negative as our outputs, then zero's got to fall somewhere in between. Let's expand our thinking, and if I have some interval and my answers, like one answer was 4 and one answer is 6, somewhere in between there, my answer should be 5 as long as it is continuous type of function and that it is not constant. So obviously if it's constant like this, it's not going to be, the output's going to be the same no matter what. So let's look here. Pick point A. We're going to talk about A, we're going to talk about point B, and we're going to pick a point C. I don't care where, just somewhere halfway in between. On this line, that makes it up here, right? So the output or the y value for this one would be called f of A. The y value for this one would be f of C, because C was over here. And then this one down here would be f of B. Okay? So taking that into consideration here, we could say that, so it is continuous. Continuous means I can draw over it with never picking up my paper, which works, or paper, my pencil. And that whatever that output is, it has to be in between A and B. Like it can't skip it. So if A is 6 here, and this is 2, this here may be 5, it may be 4, it may be 3.5, but it's got to be a number in between those two. That's what this theorem says. Okay, so let's look at some practice. First question is kind of a trick question. Would you be able to use IVT for the function h of x equals 1 over x minus 2 on the interval 1 through 3? Why or why not? So this is going to require some previous knowledge of remembering that 1 over x is the graph that looks like this. Okay, so 1 over x minus 2 would be to the right 2. So that vertical asymptote, instead of being at the x-axis, is now going to be here. So we want to think about the interval 1 to 3, okay? That interval right there. Could I use IVT? Well, does it follow the condition that it is continuous on that interval? No, because it goes down this way, and then there's a asymptote, and then it goes here. So since it is not continuous because of the asymptote, at x equals 2, we cannot use IVT. But if we look at our second example, it is an x cubed function, which hopefully your brain says, all right, that looks something like that. It could have, humps like that. But either way, it is continuous. Polynomial functions are always continuous. So that one tracks. So let's see if it has a 0 here. That means we want to find these outputs. So f of 0, what is 0 cubed minus 2 times 0 minus 1? Well, that is negative 1. What is f of 1? So that's 1 cubed plus 2 times 1 minus 1, which is 2. So we ask ourselves, does 0 fall between these numbers? This is really my brain thoughts. I shouldn't actually write that down if I'm trying to answer a question, but I like to put my brain thoughts in my notes so that when I go back and study and I can know what I was considering to get the answer. Okay, so I'm going to write some fancy letters or some fancy sentence here in math terms. By IVT, f of 0 is less than 0, and f of 1 is greater than 0. So there exists a value x equals c such that f of c equals 0. Basically, we're stating that 0 has to be in between there. And for our backup, since -1 is less than 0 is less than 2, so 0 is in the middle of -1 and 2. And f of 0 is less than f of c, which is less than f of 1. Sorry, that just says that our y values have to go in order as well. Okay, so that is all about the intermediate value theorem. Pausing here, but stay tuned for division.